Okay, so we're going to do lipid digestion. And so the digestion tag, this is L2. And digestion. And remember, tag's triacylglycerol. So we're going to take tag, and basically what's going to happen to the tag is it is going to become DAG, and we'll talk about that in a minute, but DAG's basically diacylglycerol, so there's going to be two fatty acids attached to it. And then from DAG, we're going to break it down further to MAG, which is monoacyl glycerol. And so to facilitate this, the enzyme will be lipase. And so there are different types of lipase, but the general name is lipase. And so lipases are the enzymes that act on tag. And what we're going to release is a free fatty acid. Okay? Or a NEFA. And NEFA is NEFA, is a non-esterified fatty acid. Or a fatty acid not bound to glycerol. I'm be back in like 2 seconds. I forgot my glasses. Okay, I'm back. Now it looks better. The other thing, when we do this, that we're producing is another free fatty acid, or NEFA, non-esterified fatty acid. And what the animal is going to absorb is we're going to absorb a MAG and two free fatty acids. Okay, so that's lipid digestion in a nutshell. And so in the non-ruminant, lipid digestion in the non-ruminant, we have lingual lipase. And so lingual lets you know it's occurring in the mouth. It is produced by salivary glands. Production is continuous. And production increases with increased fat intake. And something you might want to think about is why that happens. Why does increased intake of fat increase lingual lipase production? Should be pretty obvious at this point in the class, but make sure you think about that a little bit. The next enzyme we have is gastric lipase. Oh, sorry, this should be like right here. And so gastric lipase is another enzyme. It's produced by chief cells in the stomach. hence the word gastric. Again, production is continuous. And production is again increased with increased fat intake. Okay, and so we're going to abbreviate lingual lipase LL and gastric lipase GL. Okay, so lingual lipase, gastric lipase. And so lingual lipase and gastric lipase are both stable and active. At the low pH of the stomach. And they act on, or have preference for, medium to short chain fatty acids. And so this is real important because lingual lipase and gastric lipase are really important in the digestion of milk and when you're a baby. And milk contains a lot of medium to short chain fatty acids. And lingual lipase and gastric lipase remove or hydrolyze would be a better word, fatty acids from SN3 position. Okay, so that's basically what's happened in the mouth. Lingual lipase is added. We go to the stomach, we get gastric lipase. Lingual lipase and gastric lipase both work together in the stomach to remove medium to short chain fatty acids from the SN3 position of triacylglycerol. Okay? What we have next is we have emulsification. And so basically we need to define emulsification, and with emulsification what we're trying to do is increase the surface area of fat droplets. Okay, and physical emulsification occurs in the stomach via mixing and as food enters the duodenum. And so physical emulsification is basically like if you have a bottle of salad dressing with oil and vinegar, oil and water, you shake it up to get the oil off the top and you have all these little droplets of oil. That's what physical emulsification is. We're trying to make small little droplets of oil so we have increased surface area for the enzymes to attack and digest the lipid. Okay, so that's basically what's going to happen in the stomach. One thing about lipids is undigested lipids. Oh, that was like the danger zone, guys. It's like Top Gun here. Undigested lipids. If you haven't seen Top Gun, you should see it. And we also watched during the Shelter in Place Bridge of Spies. It was really good. Bridge of Spies. Tom Hanks, Steven Spielberg. Good movie. Undigested lipids presented to the ileum decrease gastric emptying. Okay, and decrease, ultimately that decreases KP. And so you kind of need to think about why you would want a slow rate of passage, slow gastric emptying if you have undigested lipids presented to the ileum. Okay, and basically it's because we're not digesting those lipids, and we really want to digest lipids because they contain a lot of energy, so we slow everything down. One of the hallmarks of consumed fat is it really slows the rate of digestion, so you get a more continual payout of food, which is maybe why you should eat some fat in the morning when you consume breakfast as a way to slow it down. This is known as the ileal brake, because basically the ileum is saying slow down, so it's putting a brake on the passage of digestion. Okay? So then we move into the small intestine. And the small intestine is where most TAG digestion occurs. So this is where we're going to have most of the digestion occurring. We're going to have basically four things happen. We're going to have an increase in pH, and everybody should be good with why that happens and how that happens. We're going to have increased emulsification. So we're going to attempt to make the fat droplets smaller and keep them small. And we're going to have lipase activity. And then we're going to have absorption. Okay. To accomplish this, first thing that happens is the gallbladder releases bile. This is bile's day. Release of bile is triggered by CCK. And we should remember CCK, and we should be able to talk about where CCK even comes from. Bile is responsible for chemical emulsification. And so with chemical emulsification, what's going to happen is we have physical emulsification, make a small droplet, and then basically bile is going to come coat that small droplet and stabilize it to keep it from forming bigger and bigger droplets. So if you take oil and water and shake them, mix them, you've created all these small droplets, and if you let it sit on the counter, eventually all the oil will rise to the top and make one big droplet. If you have bile, that's not going to happen. What's going to happen is the droplets will stay small because the bile has stabilized the lipid droplet. So bile stabilizes the fat droplet. Okay. Bile is synthesized from cholesterol. Bile's like, or cholesterol's like aspirin. No matter how many times I spell it, I don't think it looks right. So, and cholesterol we remember is, or maybe we don't remember, is amphipathic. But we should remember what amphipathic means. Okay, so that's the gallbladder and what it does. Now we're going to move to the pancreas. Start a new sheet of paper. And so in the pancreas, make sure we're good. The pancreas. So the pancreas, we're going to secrete buffer. this is again in response to CCK. We're going to secrete pancreatic lipase and pancreatic's right-hand man, or pancreatic lipase's right-hand man, procolipase. So procolipase is pancreatic lipase's friend. Pancreatic lipase hydrolyzes fatty acids from TAG at SN1 and SN3 positions. And it requires colipase for optimal activity. Okay, so colipase, where does colipase come from? We get colipase from procolipase, and procolipase is activated to colipase by our good friend from exam 3, trypsin. And colipase is pancreatic lipase's wingman. If you don't know what a wingman is, you can watch Top Gun, second Top Gun reference today. And you should watch Top Gun because it's a good movie. At least it was when I was a kid. Contains a hydrophobic. So colipase contains a hydrophobic region that interacts with a fat droplet creating, it's real blurry, we'll move it over here. So interacts with the fat droplet, creating a binding site for pancreatic lipase. Okay, so it's basically an anchor or a spot. So we have this fat droplet that we made, emulsification. We've coated that fat droplet in bile, and what's going to happen is colipase is going to create a spot. It's going to bind because it's hydrophobic. It can attach or associate closely with the fat droplet, and that creates a spot for pancreatic lipase to attach and begin to work. And so pancreatic lipase produces a mixture of MAG, which we said was monoacylglycerol, DAG, diacylglycerol, and free fatty acids. And so what this is called, this fat droplet is called a micelle. And so micelle is a fat droplet. So coated in bile, pancreatic lipase and colipase are acting on it, producing MAG, DAG, and free fatty acids. And this fat droplet, we'll draw pictures of this, interacts with the brush border. And that'd be like, you could say close contact. They get real close to each other. And so when that happens, your free fatty acids and your 2-monoacylglycerol, or your MAG, and your cholesterol, if you consume cholesterol, diffuse. So this is nice, right? We don't have a transporter. They diffuse down their concentration gradient into the enterocyte. And so this absorption is all by diffusion, happens in the distal duodenum. Not so much, but a little bit. And the jejunum, primarily in the jejunum. Okay, so this micelle, the fatty acids, the 2-monoacylglycerol, and the cholesterol basically diffuse into the enterocyte, and basically all you have left then is bile. And bile, again, headed to the danger zone. Bile is absorbed in the ileum. And one way you can lower your cholesterol when you're old enough to have high cholesterol is you can consume oat products or oatmeal or Cheerios. And basically what happens is the bile gets attached to the fiber in those products, and then it can't be reabsorbed out of the ileum. So you excrete it, so you have to use cholesterol to resynthesize bile. Whereas if you don't have it attached to something, the bile is absorbed in the ileum and returned. That's a terrible returned. Returned to the liver. And this return to the liver is known as enterohepatic circulation. So it is a circle, it is a cycle. It goes, the bile goes from the small intestine to the liver. Entero means small intestine, hepatic, liver, enterohepatic. So it's recycled through from the ileum to the liver, back to the gallbladder, to the small intestine, back through the ileum to the liver to the gallbladder, and keeps recycling. If you stop that, you have to synthesize new bile. Okay, we're going to draw an amazing summary of this. I really like it, and it's very useful. So trying to decide if we should do that in this video or a separate video. We'll stop it.